Download this code from codegive.com, link in the description below. OK, let's dive into browser noise web audio tutorial 16, focusing on data types in tone.js. This tutorial explores how tone.js handles and manipulates different data types, which is crucial for controlling synths, effects, and scheduling events in a precise and efficient way. Core concepts: understanding data in web audio and tone.js. In the world of web audio and tone.js, data types are essential for a few key reasons. Accuracy and precision. Sound synthesis often requires precise control over parameters like frequency, amplitude, time, and more. Using the appropriate data types ensures that the values are interpreted correctly and accurately. Efficiency. Web audio processing can be computationally intensive, especially when dealing with complex sounds or many simultaneous voices. Optimizing data types can improve performance, preventing slowdowns or stuttering. Flexibility and control. Different data types offer different capabilities. For example, you can use numbers for static values, strings for note names, or arrays for complex sequences. Understanding these differences allows you to create a wide range of sonic textures and musical structures. Data types in tone.js, a detailed overview. Tone.js uses a variety of data types, often building upon the standard JavaScript data types but adding its own custom types to handle audio-specific needs. Here's a breakdown. 1. Numbers, numeric values. This is the most fundamental data type. Numbers are used to represent things like frequency, in hertz, amplitude, 0.0 to 1.0, time, in seconds, duration, in seconds, gain, in decibels, and many other parameters. Tone.js uses JavaScript's number data type internally for most numerical calculations. 2. Strings, textual data. Strings are used primarily for representing note names, example C4, A5, EB3, musical durations, example 4N for a quarter note, 8T for an eighth note triplet, and sometimes for other descriptive labels. 3. Booleans, true/false. Booleans represent a binary state, true or false. They're used for enabling/disabling features, switching between states, or conditional logic. 4. Arrays, lists of data. Arrays are incredibly versatile. They can store sequences of notes, rhythms, parameter values, or any other kind of data. They are crucial for creating complex musical patterns and automation. 5. Objects, key value pairs. Objects are used to represent structured data. They consist of key value pairs, where the keys are strings and the values can be any data type. Objects are ideal for configuring synths, effects, and other tone.js components. 6. Tone.time, time data type. This is a very important custom data type in tone.js. Tone.time allows you to express time values in various formats. Seconds, raw time in seconds, example 1.5 for 1.5 seconds. Musical notation. Using musical notation like 4n, quarter note, 8t, eighth note triplet, 1m, 1 measure. This is relative to the transport's tempo and time signature. Frequency. Representing time as a frequency, example 4 Hz means 4 cycles per second, so the duration is 0.25 seconds. Samples. Number of audio samples. Tone.time is essential for scheduling events accurately in relation to the musical timeline. 7. Tone.frequency, frequency data type. Asterisk tone.frequency is a custom data type designed for representing frequencies. It can interpret frequency values in different formats. Asterisk Hertz, Hertz the standard unit of frequency, example 440 for 440 Hz. Asterisk note names asterisk using note names like C4, A5, etc. Tone.js will automatically convert these to their corresponding frequencies. Asterisk MIDI note numbers asterisk representing frequencies using MIDI note numbers, example 69 for A4. A tone.amplitude, amplitude/gain data type. Asterisk tone.amplitude is used to represent amplitude or gain values. While you can use regular numbers, 0.0 to 1.0, for amplitude, tone.js often expects values in decibels, dB, for gain. A value of 0 dB represents the maximum possible amplitude, no attenuation, and negative values indicate attenuation. Working with data types in tone.js, best practices. Asterisk understand the expected data type asterisk always consult the tone.js documentation to determine the expected data type for a particular property or method parameter. Using the wrong data type can lead to unexpected behavior or errors. Asterisk use tone.time and tone.frequency for scheduling and frequency control asterisk these custom types provide a more flexible and intuitive way to work with time and frequency values compared to using raw numbers. Asterisk use the conversion functions asterisk tone.js provides utility functions like tone.frequency, tone.time, tone.db to gain, and tone.gain to dB, to convert between different data representations. Use them to ensure that your data is in the correct format. Asterisk be aware of context asterisk the interpretation of a data value can depend on the context in which it is used. For example, a number might represent seconds in one case, but a frequency in another. Pay attention to how the data is being used. Asterisk use arrays and objects for complex structures. If you want to represent a set of parameters of a sound, or a group of notes, you can use arrays to store the data. If you need parameters that has a name, you can store that data in an object. Code example, combining data types for a simple sequencer. Let's put these concepts together to create a very basic sequencer that uses different data types. In this example, asterisk notes is an array of strings representing note names. Asterisk durations is an array of tone.time values representing musical durations. Asterisk volumes is an array of numbers representing the amplitude in dB. The sequencer iterates through these arrays, combining the data to trigger notes with different pitches, durations, and volumes. This example demonstrates how understanding and combining different data types can be used to create interesting and dynamic musical patterns. Troubleshooting. Asterisk type error, cannot read property value of undefined. This often means you're trying to access a property on an object that doesn't exist or hasn't been initialized yet. Double check your variable names and that you're creating the necessary tone.js objects. Asterisk sounds are too quiet or too loud, check the volume/gain levels. Remember that tone.js generally works with dB values, so you might need to use tone.db to gain, to convert dB to a linear gain value, 0.0 to 1.0. Asterisk timing is off, make sure you're using tone.time values correctly and that the tone.transport is running. The tempo, BPM, of the transport will affect the interpretation of musical durations like 4n. Asterisk nothing is happening, double check that your audio context is started, often requires a user interaction. Make sure your tone.transport is started. And verify that your synth/instrument is connected to tone.destination. This detailed explanation should give you a solid understanding of data types in tone.js. Remember to experiment, explore the documentation, and build your own creative projects to solidify your knowledge. Good luck, and have fun making music.